Today we're going to continue our work with solving equations that have variables on both sides. We're going to look specifically at the number of solutions that these types of equations can have. You should be on page 10 in your notes packet. Equations that have variables on both sides are actually very unique because these can have one solution, which is what all of the equations that we have solved so far have. No solution, or infinitely many solutions. So there are ways that you can figure these out. So we're going to look at this. When you have one solution, there is only one number that can make that equation true. So when you solve the equation, you can isolate the variable on one side of the equation. So you would have an equation that might say x equals 3 or some number that's over here. When you have no solution, it is impossible to make the equation true. There is no way that that equation will ever be balanced. So when you simplify both sides of the equation, what you'll notice is the coefficients on those variables are going to be the same. So for example, you might have 3x and 3x, but the constants are going to be different. So I might say plus 5 over here and minus 6 over here. Well, if I canceled those 3x's out by subtracting 3x on both sides, I would be left with something that said 5 equals negative 6. Well, this is an untrue statement. It is never going to be true that 5 is equal to negative 6. So this would tell me that I would have no solution to this equation. When you have an equation that has infinite solutions, that means that you could plug in any number for that variable, and your equation is going to be true. And this happens because the equation starts out perfectly balanced. So when you simplify both sides of the equation, what you'll notice is that you would have coefficients and constants that would be the same. So that might be something like 2x minus 5 equals negative 5 plus 2x. Well, in both of these, they have a coefficient of positive 2 and a constant of negative 5. If I would subtract 2x from both sides, I'd be left with negative 5 equals negative 5. Well, in this case, I would have an equation that has both sides perfectly balanced, and I could tell that there would be infinite solutions to this equation. So let's look at some examples. Our first example says 5 times 4x minus 2 equals 2 times 10x minus 5. Well, I can see here that both of the sides of this equation need to be simplified, and I would use the distributive property to do that. So I'm going to start by multiplying 5 times everything in this parentheses. Well, 5 times 4x gives me 20x, and 5 times negative 2 gives me negative 10. On this side of the equation, I would need to distribute my 2 to every term. 2 times 10x would give me 20x, and 2 times negative 5 would give me negative 10. Now, if I stop here and just look, I see that both sides of my equation have the same coefficient. So I have a 20 and a 20. I also see that the constant is the same. So I have negative 10 and negative 10. I should be able to stop here and see both the coefficient and the constants are the same, so I should know that there are infinite solutions. But if you have a hard time telling, that's okay, because you can still work this out just like we would any equation that has a variable on both sides. I would get rid of one of them, so since this is a positive 20x, I would subtract 20x from both sides. Well, 20x minus 20x would cancel, and I'd be left with negative 10. This 20x minus 20x is also 0, and I would also be left with negative 10. Well, I'm left with an equation that doesn't have any more variables, but it's telling me that negative 10 is equal to negative 10. What this means is I could plug in any number for x and this equation would be balanced. So this equation has infinitely many solutions. A big mistake that people make here is that they see negative 10 equals negative 10 and they want to tell me that negative 10 is the solution. That's not actually true because you are not seeing that x is equal to negative 10. What you're seeing is that you have an equation that is perfectly balanced, so this tells you that there are infinite solutions. Now for our next equation, you can see that we're going to need to distribute again. So we're going to distribute negative 3 into our parentheses. Negative 3 times positive 2x is negative 6x. Then negative 3 times positive 1 is negative 3. So I would write minus 3. On this side of my equation, I need to distribute my negative 6. Well, negative 6 times x is negative 6x. Then negative 6 times negative 1 is positive 6, so I would write plus 6. Well, if we stop and look at this, you can see that you have the same coefficient. So you have a negative 6 and a negative 6. However, you have different constants. So you have a negative 3 as a constant on the left side and a positive 6 as a constant on the right side. Since you would have the same coefficient but a different constant, you should be able to recognize that there is going to be no solution to this equation. However, if you can't recognize that, you can still solve like normal. If I were wanting to eliminate negative 6x, I would do positive or plus 6x on both sides. Well, negative 6x plus 6x is 0, and then I would be left with negative 3. On this side, negative 6x plus positive 6x is also 0, but I would be left with 6. Well, you're not left with an x anymore. You're just left with a statement that says negative 3 is equal to 6. We know that this is not true. At no point in time is negative 3 ever equal to 6. So what you have is an equation that cannot ever be balanced. So this equation has no solution. Now let's look at our next one. We see that we need to distribute our negative 2. Negative 2 times positive 4x is negative 8x. Negative 2 times negative 15 is positive 30. We also have plus 13x here, and we can't forget about it, so we're going to rewrite it. On the right side, we need to distribute our 5. 5 times x is 5x, and 5 times 6 is 30, so positive 30. Now, when you look at the left side, I still have x's that are like terms that need to be combined. So I have negative 8x plus 13x. Negative 8x plus positive 13x gives me positive 5x. And I still have this plus 30 that I need to rewrite. Now on the right side, this also says 5x plus 30. Well, what you should notice here is that we have the same coefficient of 5, and we also have the same constant of positive 30. Because the coefficients and the constants are the same, I should recognize that this is going to be infinite solutions. Again, if you can't recognize it, that's okay. You can start moving your variables, so I would subtract 5x from both sides. Well, 5x minus 5x cancels to leave me with positive 30. This 5x minus 5x cancels to also leave me with positive 30. Well, I'm left with an equation that has no variables, so there's not a solution to the variable. What I'm left with is an equation that is just perfectly balanced because 30 is equal to 30. This tells me that I will have infinitely many solutions to this equation. Next, we have 3 minus 8n equals 2 times negative 4n plus 1. You see there is no simplifying to do on the left side, so I'm just going to rewrite that. On the right side, I would need to distribute 2. 2 times negative 4n is negative 8n, and 2 times positive 1 is plus 2. Well, now I have 3 minus 8n equals negative 8n plus 2. If I look at my coefficients, I see that I have a coefficient of negative 8 here and a coefficient of negative 8 here. But when I look at my constants, I see that I have a constant of 3 and a constant of 2. Since my coefficients were the same, but my constants were different, that should tell me that there will be no solution. Again, if you can't tell, you can still work this out. So you have a variable on both sides, so you would want to get rid of them, or one of them. So since right here I'm subtracting 8n, I could use the inverse, which is adding 8n on both sides. Well, negative 8n plus positive 8n is 0. So these would cancel, and I'm left with 3 on the left side. Negative 8n plus positive 8n is 0 again, and I'm left with positive 2 on the right side. Well, I'm left with an equation that says 3 is equal to 2. That is not true. At no point will that ever be true. So this equation has no solution. Next, I have 1/4 times 8x minus 12 plus 3x equals 3x minus negative 2x plus 3. Well, I would distribute my 1/4 first. So remember, when we're multiplying by a fraction, if I'm multiplying 1/4 times 8x, I can put my whole number over 1 and multiply like normal. 1 times 8x is 8x. 4 times 1 is 4. So this says 8x divided by 4, which is 2x. So 1/4 times 8x is 2x. Now I also have to multiply 1/4 times negative 12. Again, I can put that over 1. 1 times negative 12 is negative 12. 4 times 1 is 4. So this says negative 12 divided by 4, which is negative 3. Because that 3 is negative, I would write minus 3. Now on the left side of my equation, I still have plus 3x, so I need to write that. Now, on the right side, I have 3x. Well, I'm just going to have to rewrite that for right now. You see I have this parentheses and a minus sign in front of it. This means that I am technically distributing a negative 1 into my parentheses. Well, negative 1 times negative 2x is positive 2x, so I would write plus 2x. Negative 1 times positive 3 is negative 3, so I would write minus 3. Now, when I look at the left side of my equation, I still have some like terms. So I would need to put 2x plus 3x together. Well, 2x plus 3x gives me 5x. And I still have this minus 3, so I'm going to rewrite that. On the right side, I also have like terms of 3x plus 2x. Well, 3x plus 2x is again 5x. And I also have a minus 3 over here. Well, at this point, I can see that I have the same coefficient of 5 and the same constant of negative 3. So there will be infinitely many solutions to this equation. For my next equation, I see that I can't do anything with negative 7x, so I'm just going to rewrite that. But I do need to distribute positive 2. Positive 2 times positive 8 is positive 16, so I'm going to write plus 16. Positive 2 times positive 6x is positive 12x, so I'll write plus 12x. On the right side, I need to distribute this 1/6 into my parentheses. Well, 1/6 times 18x gives me 3x. Then 1/6 times positive 36 gives me positive 6, so plus 6. Now we also have this minus 8 we need to rewrite so we don't forget about it. Well, when I look at the left side of my equation, I see some like terms. I have negative 7x plus 12x. Negative 7x plus positive 12x is positive 5x. And I still have this plus 16, so I need to rewrite that. On the right side of my equation, 3x does not have a like term, so I'm rewriting that. But 6 minus 8 are like terms. So this is positive 6 minus 8. If I do 6 minus 8, that gives me negative 2. So I would write minus 2. Now, if you look at this equation, both sides are simplified. What you should notice is that I have a 5 for a coefficient on the left side and a 3 as a coefficient on the right side. Well, this is the same sort of equation that you were working out. You have two different coefficients. If your coefficients are different, that tells you that you will have one specific solution for this equation. So you are going to solve this like normal. Remember, I typically try to move the variable that has the smaller coefficient. So since 3 is smaller than 5, I'm going to move my 3x. Since it's a positive 3x, I'm going to subtract 3x from both sides. 5x minus 3x gives me 2x, and then I need to bring down plus 16. 3x minus 3x is 0, so these cancel, and I'm left with this negative 2. Now I have a two-step equation, and now I could solve like normal. Well, I would start by getting rid of this plus 16. So I would subtract 16 from both sides. 16 minus 16 is 0, and I'm left with 2x. Negative 2 minus 16, and you have to be careful with that. This says exactly what you see written, nothing more. Negative 2 minus 16. That gives me negative 18. Then to get x by itself, I need to get rid of the 2, so I'm going to divide by 2 on both sides. Those cancel and leave me with x, then my equal sign. Negative 18 divided by positive 2 is negative 9. So this means that x equals negative 9. When you're left with an x equal to something, that means you have one solution. So the only solution that will work here is when x is equal to negative 9. For our next equation, we need to distribute our 5/12 into our parentheses. So we would do 5/12 times 60x. Well, remember that 5, when we have a fraction times a whole number, we're going to put a 1 under it. So 5 times 60x gives me 300x. And then 12 times 1 gives me 12. So I have 300x divided by 12. When I divide 300 by 12, I get 25. So this is 25x. So 5/12 times 60x gives me 25x, but I also need to multiply 5/12 times negative 120. Well, again, since negative 120 is a whole number, I'm going to put it over 1. Well, 5 times negative 120 is negative 600, and 12 times 1 is 12. Well, when I divide negative 600 by positive 12, I get negative 50. So since that 50 is negative, I would write minus 50. Now you also have plus 11 on the left side, so we're going to rewrite that as well. Well, now on the right side, we need to distribute our 3/4 into this parentheses. So we're going to do 3/4 times 24x. Well, remember, we'll put a 1. So 3 times 24 gives me 72. So that is 72x. 4 times 1 is 4. And then if I do 72x divided by 4, I'm left with 18x. So 3/4 times 24x is 18x. But remember, we also need to multiply 3/4 times negative 60. Well, we'll put a 1 under that and we'll start multiplying. 3 times negative 60 is negative 180. 4 times 1 is 4. Well, negative 180 divided by positive 4 gives me negative 45. Since it's negative, I would write minus 45. Now, I still also have this negative or minus 29 over here. Well, when I look at both sides of this equation, I can see that neither side is simplified. Now, on the left side, I do not have a like term with 25x, so I would just rewrite that. But negative 50 plus 11 are like terms. You have to remember that that is a negative 50, so you should do negative 50 plus positive 11, which would give you negative 39. I would write minus 39. On the right side, 18x does not have a like term, so I would rewrite that. Now, but I do have negative 45 minus 29. Well, remember, you would need to put that in your calculator as that exactly how it's written. Negative 45 minus 29. That would give you negative 74. So you're left with 25x minus 39 equals 18x minus 74. You can see that you have different coefficients, so you know that you're going to have one solution here. Now, what I'm going to do is get x on one side, so I'm going to subtract 18x from both sides of this equation. 25x minus 18x gives me 7x, and I still have minus 39. Over here, my 18x's will cancel, but I'm left with negative 74. Well, now I need to add 39 on both sides of this equation. My negative 39 plus 39 cancels to leave me with 7x. Well, negative 74 plus positive 39 is negative 35. To get x by itself, I'm now going to divide by 7 on both sides. So these will cancel, and I'm left with x equals negative 35 divided by positive 7 gives me negative 5. So my solution is that x equals negative 5, which tells me that I just have one solution to this equation. Next, let's do 11x minus 3x plus 8 plus 12 equals 2 times 2 plus 4x. Well, I can't do anything with 11x. I'm just going to rewrite it. Right here, I need to distribute a negative 1, so that negative 1 is invisible, but it's still there. Negative 1 times positive 3x is negative 3x, so I write minus 3x. Negative 1 times positive 8 is negative 8, so I write minus 8. We also have plus 12, so we also need to rewrite that. On the right side of our equation, we also need to distribute this 2. 2 times 2 is 4, and then 2 times positive 4x is positive 8x. So we have 4 plus 8x. Now on the left side of our equation, we notice that we have a lot of simplifying that we can do. We have 11x minus 3x. Well, that would give us 8x. Then we have negative 8 plus positive 12. If we add negative 8 plus positive 12, we get positive 4, or plus 4. On the right side, that side is already simplified, so I can just rewrite 4 plus 8x. Well, we should notice here that we have the same coefficient of 8, and we have the same constant of positive 4. That should tell us that there are going to be infinite solutions here. So for this equation, there are infinitely many solutions. For negative 9 times x minus 8 minus 51 equals 3 times negative 4x plus 11 plus 9, I would start by distributing negative 9. Well, negative 9 times x is negative 9x. Negative 9 times negative 8 is positive 72. Then I still have minus 51, so I'm going to rewrite that. On the right side, 3 times negative 4x is negative 12x. 3 times positive 11 is positive 33. And I still have plus 9. Now on the left side, I don't have any variables that can be combined, so I'm just rewriting negative 9x. I do have positive 72 minus 51. Well, 72 minus 51 is positive 21, so I would write plus 21. On the right side, negative 12x does not have a like term, so I would rewrite that. And 33 plus 9 gives me positive 42. Well, I can see here that I have a variable on both sides, but they have different coefficients. That tells me that I'm going to be working with something that has one solution. I'm going to start by moving one of my variables. Since I know that negative 12 is smaller than negative 9, I'm going to move my negative 12x. Well, I'm going to do the inverse of this minus 12x, which is plus 12x, on both sides. Well, negative 9x plus positive 12x gives me positive 3x. I still have this plus 21 over here that I need to rewrite. Negative 12x plus positive 12x is 0, and I'm left with positive 42. Well, now I just have a simple two-step equation. I'm going to subtract 21 from both sides. 21 minus 21 will cancel to leave me with 3x equals, and 42 minus 21 gives me 21. To get x by itself, now I need to divide by 3 on both sides. My 3's will cancel to leave me with x equals, and 21 divided by 3 is 7. So x equals 7, and this tells me that there is one solution to this equation. For my next equation, I'm going to start by distributing negative 2. So negative 2 times positive 4x is negative 8x. Negative 2 times negative 8 is positive 16. And then I have plus 3 here that I can't forget about. On the right side, I need to distribute my negative 3. Well, negative 3 times positive 2x is negative 6x. Then negative 3 times positive 4 is negative 12. And I still have minus 2x out here. Well, on the left side, I have negative 8x that does not have a like term, but I do have 16 plus 3. Well, 16 plus 3 gives me positive 19. On the right side, I have negative 6x and minus 2x. Well, that's like saying negative 6x minus 2x. When I do negative 6 minus 2, I get negative 8, so this is negative 8x. And I also have this minus 12 here. Well, at this point, I can see that I have the same coefficient of negative 8 on both sides. But I have a different constant. I have a positive 19 and a negative 12. That means that those negative 8x's will cancel out, and I'll be left with 19 equals negative 12. That tells me that there will be no solution to this equation.